This video will explore the various ways functions can be called or invoked in JavaScript. We will cover the different methods of invocation, their impact on this context, and best practices for utilizing them effectively. There are primarily two broad categories of function invocation: regular and method invocation, constructor and indirect invocation. A regular function invocation occurs when a function is called as a standalone function, that is, not as a method of an object. The value of the this keyword inside the function depends on whether the code is running in strict mode or not. In strict mode, this will be undefined. When not in strict mode, this refers to the global object, which is typically the window object in browsers. Here is an example. First, we define a function called greet. Inside the function, we log the value of this and then return a string hello. Then we call this function, and whatever the value is returned is stored in the variable result. So result contains hello. When a function is called as a method of an object, it is known as method invocation. In this case, the this keyword inside the function will refer to the object the method belongs to. Let us see some examples. First, we create a user object with properties name and greet. The greet property is a function that returns a greeting message that includes the user's name by using this .name. When we invoke the method greet using user.greet, the this keyword correctly references the user object. Next, we create another object named calculator, which has a value property and add property. The add property is a function that adds a number to the existing value. It also returns this, enabling method chaining. Constructor invocation is used to create objects from a function, using the new keyword. When a function is called with the new keyword, several things happen. First, a new empty object is created and assigned to this. Second, the object's prototype is set to the constructor's prototype. Third, the constructor function is executed with the new object as the context, that is, this refers to the new object. Fourth, the new object is returned automatically, unless specified otherwise. In this example, we are creating a function named user. Inside the function, we are assigning name and age to the object using this. We are also creating a greet method for this object. Then we use the new keyword to create a user object. The user object then has a greet method as a result of constructor invocation. Indirect invocation allows you to explicitly set the value of this when a function is called. The call method along with apply is one way to do this. The call method accepts the context to be bound to this as the first argument, and any other arguments are passed to the function individually as comma-separated values. Let us see an example. We have a person object with a name property and a greet function that accepts a message and an emoji as parameters. We are calling the greet function with the call method, passing the person object as the context, the greeting hello, and waving hand emoji. The value of this inside the function now refers to the person object. So when greet accesses this .name, it gets the name John from person object, and therefore it returns hello John and the waving hand emoji. The apply method is similar to the call method, in that it also allows setting the this context explicitly. However, instead of taking arguments individually, it accepts an array of arguments to be passed to the function. This is particularly useful when you have arguments already in an array. The call method accepts arguments as comma-separated values, for example, func.call with context argument 1, argument 2. However, the apply method accepts them as an array. For example, func.apply with context and an array of arguments. This makes it particularly useful with array methods and when using spread operations. Now let us see a practical example. First, we create a number array, and then we use the apply method of math.max to find the maximum of this array. The context is set to null since it is not needed here. And next, we create a calculator object and a multiply function that uses the multiplier property. This demonstrates how apply method can be used to set custom context as well. Method borrowing is a pattern that allows using methods from one object on another object that may not have those methods defined, but has a similar structure. One of the primary use cases of this pattern is to borrow array methods for array-like objects. Let us see an example. We have a function named sumargs that takes any number of arguments. We are borrowing the reduce method from the array prototype and using it on the arguments object, which is an array-like object, and it adds all the arguments passed to this function. This demonstrates method borrowing of an array method. Next, let us see an example of borrowing method from an object. We have two objects, person and robot, with similar structure, that is, they both have a name property, but the robot does not have a greet function. So, we are borrowing the greet function from person using the call method and applying it to the robot, and that's why it gives hello R2D2. Function binding is a pattern that allows you to create a new function with the this keyword permanently bound to a specific value. You cannot change the bound this context using methods like call or apply. It is extremely useful in situations that involve callbacks and event handlers. Let us see an example. We have a user object with a greet method that takes a greeting message as a parameter. Then we are creating a new function called boundGreet using the bind method, with the context as the user object. We also created another function called sayHello with bind with the user context and hello as a parameter. When we call boundGreet and give a greeting message like hi, it will output hi Alice. And when we call sayHello, it will output hello Alice. These showcases how to use bind to achieve partial application and also fix the this context. Understanding common pitfalls in function invocation, specifically with the this context, is very important to write bug-free and reliable code. Let us explore some common mistakes. One common mistake is losing context in callbacks. In this example, we have a user object with a greetLater method. The setTimeout function is called inside greetLater, and it uses a normal function expression as callback. In this case, this will not refer to the user object but will be either undefined in strict mode or the window object in non-strict mode. A solution to this would be using an arrow function as callback. The other common pitfall is method separation. In this example, we are separating the greet method from the object. When we call it this way, the context is lost and it results in error. The solution is either to use bind method or an arrow function for preserving the context. Arrow functions behave differently from regular functions when it comes to the this keyword. Arrow functions do not have their own this binding. They inherit the this value from the enclosing lexical scope, which is the scope where the arrow function is defined. Also, arrow functions cannot be used as constructors, and they do not have the arguments object available. The this value in arrow functions cannot be changed with methods like call, apply, or bind. Let us see an example. In the object we have a value property and a getValue method that uses an arrow function to access the value property using this. Here, this refers to the enclosing scope. One of the major use cases of arrow functions is to avoid context loss in callbacks and event handlers. In this example, we have a handler class and we have handleClick method as arrow function. This will always refer to the handler instance. Also in the process method, the setTimeout uses an arrow function and that ensures there is no context loss. Let's explore some modern patterns in JavaScript, using the newer features of ES6 and beyond. One of the important ones is method shorthand and class fields that help define methods and class instance properties in a concise way. In this example, we are creating a task manager class, and we are using a class field with an arrow function to define handleTask method. And we are using method shorthand to define the process method. Method shorthand makes code more readable and less verbose, and class fields help eliminate the need to use a constructor and bind methods. Another important pattern is function composition. It uses functional programming principles to combine functions, using modern chaining patterns. In this example, we have a pipe function that composes functions together and processes the data step by step. The functions to be composed are passed in an array. Here are some of the best practices and key takeaways related to function invocation. It is important to manage the context properly. For callbacks, using arrow functions is a good way to preserve context. Methods need to be explicitly bound when they are separated from objects. Class fields should be used for instance methods that need binding. Methods can be borrowed from other objects using call and apply. It is also important to use the new modern patterns available. Always utilize method shorthands in object literals. And also use class fields for bound methods for cleaner code. This helps you improve code quality and avoid the common pitfalls associated with JavaScript function invocation. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.